Hey y'all, in this lesson we are looking to connect proportional relationships with the idea of slope. Our essential question is, what is slope? By the end of this lesson we want to be able to say, I can find the slope of a line using different strategies. So let's start off with, in proportional relationships, slope is the same as unit rate or constant of proportionality that we learned about in lesson 1. So let's continue to explore slope. In example 1, we're going to find slope using 2 points on a graph. The graph here represents the depth of a diving submarine over time. At what speed is it going down or descending? We're going to find the slope of the line, and as you can see here, slope is represented by rise over run, or the difference in my y values over the difference in my x values. Now we use that little, we call it sub 1 and 2 to really just say the y value from point number 1 and the y value from point number 2, the x value from point number 1 and the x value from point number 2. Here we can get that our point number 2 is the 10 negative 800. So you see that here my y is negative 800 and my x is 10. Point number 1 is 5 negative 400. So I have negative 400 for y and 5 for x. So I just put those numbers in, and I can use a calculator to help me find that this is going to be negative 400 over 5. Negative 800 minus negative 400 is negative 400, and 10 minus 5 is 5. We can simplify this further by dividing it out, and we get negative 80. That negative makes sense because we are going down. It is diving. So the slope of the line is negative 80, and in context of our problem, the submarine is descending at a rate of 80 feet per minute. Here's an opportunity for you to try. The graph here shows the proportions of red and blue food coloring that Taylor mixes to make purple frosting. What is the slope of this line? Tell what it means in the problem situation. Use the same method to find the slope of this line. When you are done, pause the video now. When you are done, press play to see the answer. All right. In this problem, we're going to have 70 minus 35 on the top of our fraction and 50 minus 25 on the bottom. This will give us 35 over 25, which we can simplify to the slope being 7 over 5. 7 over 5. If we put that in a decimal, it would be 1.4. So this means for every increase in blue drops, we would have to do 1.4 or 7/5 more red drops. So again, the slope is 7 over 5 or 1.4, and that number should be used to fill in both blanks here. Let's look at another word problem, really more understanding slope. So here's a situation where we would actually use this idea of slope. Maya and her father are building a treehouse. The roof will have a 9/12 pitch. That is, for every 12 inches of horizontal distance, we see here 12 inches on the bottom, the roof rises 9 inches. So every time we go over 12 inches, we have to go up 9 inches. Over 12, up 9, over 12, up 9. That helps us put in the proper supports. How can Maya determine the height of the roof at its peak? So you can see here, from the edge to the peak is 6 feet. So we're wondering essentially how many 12 inches are in that 6 feet and how many do we have to go up 9? Well, here we can make a table of values. You can see my table of values created here. Make sure you fill in yours. So we know that every time we go up 9 or go over 9, every time we go over 12, we're going to go up 9. So we have 9 and 12. If we go over another 12 to get to 24, we're going to go up another 9 to get to 18. Over another 12 to get to 36. Up another 9 to get to 27. Each time you can see my vertical divided by my horizontal distance, 9 over 12, 18 over 24, 27 over 36. They are all reducing to 3/4. So I have a slope here of 3/4. Now, I want to graph the ordered pairs from the table and draw a line to connect them. This can help me actually visualize the line and see where it's going. Now, I can see that that line extends a little bit further. This is where I want to put a point because 6 feet is 72 inches. And when you add 12 to 60, you get 72. So this next point is the point that I want to focus on. This is going to be at 72.54. And I can see that it's here halfway between 48 and 60. And so that spot is 54. So I know that this is at 72.54. Now, Maya can use this graph to find that the roof is 54 inches in height at its peak. Again, we do need to be able to convert between inches and feet in order to figure this out. So just keep that in mind. If you need to go back and rewatch this, keeping that in mind, please do. But we used our slope that it is going over 12 and up 9 to get that height at 6 feet is 54 inches. You try it with this one. Jack graphs how far he plans to bike over a 3-day charity ride. Find the slope or the amount he's biking per day. Again, slope is the rise over the run. So how much is he rising up? And how much is he running over? We're going from day 2 to day 3. Use that to indicate the slope of the line. Pause the video, do this problem, and press play when you're ready to see the answer. In this case, the rise is 30. We're going from 60 to 90, which is up 30. And the run is 1. We're going from 2 to 3. So we have 30 over 1. So the slope of this line is 30. Let's summarize. As we connect proportional relationships with slope, we want to remember that slope is the measure of steepness of a line. It represents the ratio of rise, which is vertical distance, to run, which is horizontal distance, between 2 points on a line. In proportional relationships, the slope is the same as the unit rate. So if you find the unit rate of a proportional relationship, you have found the slope. Here again are 2 ways we use to find slope. What is known as the slope formula, rise over run, or y2 minus y1 over x2 minus x1, and by looking at a graph. Your next steps are to turn in your 5.2 notes, complete your 5.2 practice, and complete your 5.2 mastery check. Good luck, and I'll see you in the next lesson.